Today we are going to study peroxide ion, that is O2 minus. O2 minus. Okay. So peroxides are diamagnetic in nature. On the basis of valence bond theory, oxygen atom has electronic configuration in the ground state. See, in the ground state, what is the electronic configuration? 1s2, 2s2, 2p4. So 2s2, 2p4. This is the outer shell, right? So 2s2, here 2 electrons are there, and 2p4. Okay, so one electron here, first one, second one, third one, and fourth one electron comes again to the this shell. Okay, this over here. Okay, so now see how many unpaired electrons are there. There are now 2 unpaired electrons. One of the electron is here, and other electron is here. These 2 electrons are the unpaired electron. Okay, so in the ground state, electronic configuration of O minus ion is, see, 1 electron is there now extra, right? So what happens? Next electron comes to this cell. Okay, it comes over here, right? So how many number of unpaired electron left? Only 1 unpaired electron is left over here. So during the formation of peroxide ion, both O minus ion overlap to form O2 minus ion. O2 minus ion, in which both singly filled sp3 hybrid or orbital overlap together. Okay, so 3 lone pair of electron do not participate in bond formation, right? So there is a no unpaired electron. There is a no unpaired in electron. Okay, in the peroxide ion, hence it is a diamagnetic. Where here it is. Okay, what happens here? 2 electrons are there. Okay, so no unpaired electron is there in that case. Where in the case of, see here now, in this case you can see only 1 unpaired electron is there. Only 1 unpaired electron there. So 2 oxygen atoms are linked together by a normal covalent bond over here, and 3 electron bond. How many electron bond are there? See, 3 electron bond. Presence of 1 unpaired electron in 3 electron bond explain paramagnetic nature of superoxide. So why it shows a paramagnetic nature? It has a 1 unpaired electron. It has a 1 unpaired electron, and that is the reason in the magnetic field it shows the effect of magnetic field. Okay, so it is a paramagnetic in nature. So see here, one O atom, other O atom combine together to form O2 molecule. Okay, and here, see, this is on the basis of molecular orbital theory. Yeah, this is what we are looking for. See, now O2 atom, O2 molecule is there. So it combines, or it takes 1 more electron. So what it forms? It forms O2 minus. So this should be to this side. Okay, ite nasawa. Okay, printing mistake. So this is minus. Okay, so 16 electron plus 1 electron. 1 odd electron is there, and that makes this molecule. That makes this molecule paramagnetic. Which molecule? This molecule. Okay, but it has, but O2 minus, O2 2 minus has no unpaired electron. Hence it is a diamagnetic, but here it is a paramagnetic. Okay, this is what the case is. So you can see here again. So this is a ground state of oxygen atom, and this is again ground state of O minus atom. Okay, and it has 1 unpaired electron over here. But when 2 O minus combine, it get paired with the other one. Okay, now what is hybridization over here? sp3. Hybridization is sp3 for the formation of O2 2 minus. Okay, now hydrides of the group 1 and group 2. Now group 1. So hydrides where the element combined with the hydrogen. Okay, alkali and alkaline earth metal element combined with the hydrogen, and they form a compounds called hydrides of that elements. Okay, so alkali metal react with the dihydrogen atom. Okay, at about 376 Kelvin, 373 Kelvin. Okay, and lithium takes more temperature for the reaction to form hydrides. See here, these are the metals. lithium, potassium, rubidium, sodium, they forms EMH hydride, right? This is the hydrogen gas. So when metal react with the hydrogen gas to form hydride, this reaction is need to be carried out under very controlled condition, because we know that hydrogen gas is explosive in nature. So we need to take proper care while carrying out these reactions. Okay. So ionic hydrides are solid and they are very thermally stable. Okay, they have high melting point and boiling point. Ionic hydrides have high melting and boiling point, and they are soluble in the water. Okay, they are soluble in the water and insoluble in organic solvent because they are ionic in nature, and we know that ionic substances are more soluble in the water and insoluble in the organic solvent. So they are again, as due to the ionic nature, they are good conductor of electricity. They are good conductor of electricity, so they can easily react with the water and they forms the base. They forms base. So again we can see here that sodium hydride react with the water to form sodium hydroxide. Potassium hydride react with water to form potassium hydroxide. Okay, then sodium hydride react with the HCl to form sodium chloride, and lithium hydride react with HCl to form lithium chloride. Okay, so these are the thing over here. But remember, these reactions are not that much easy to carry out. Even don't try. So one of the incidents happened in the Rotary School, that blast was happened over there when I was as a referee for the some kind of program over there. Okay, so students were standing over there, and I think symposium was there, some kind of symposium. Okay, so just like you know. At that time, the kids were doing experiment in chemistry, and I found that there is a depletion of hydrogen gas was taking place. So instantly, I asked them to keep it away. And at the 5 to 10 minutes only after that, the blast was happen over there. So these are not easy reactions to carry out. Be careful while doing such a reaction. Okay, remember. Now, reaction with ethyl alcohol. Reaction with ethyl alcohol. What happened now? So this sodium will take the position of this hydrogen and formation of sodium salt of ethanol. Sodium salt of ethanol. So hydrides of group first are more reactive than the hydrides of group second. Okay, and the reactivity of these hydrides of first group element goes on increasing down the group. Okay, and these hydrides of first group element are used to produce hydrogen gas. Okay, they are also used as a reducing agent for the metallurgic processes, and they are used as a dehydrating agent. Dehydrating agent. Now we'll see that group second hydrides. Group second hydrides. So alkali metal hydrides have general formula. Which one? MH2. MH2. Except beryllium, all element of this group combined with the hydrogen to form hydride. But to form the hydride of beryllium, we need to carry out this process. Beryllium chloride reacts with the lithium aluminum hydride, and that forms the beryllium hydride. Okay, so this is what the exception to form the hydride of beryllium. Remaining of the element directly react with the hydrogen gas and they form their respective hydride. See here, these are the metals. Okay, reacts with the hydrogen and they form metal hydride. So again, calcium hydride. See what happens when reacted with the water. Calcium hydride, when reacted with the water, it forms corresponding hydroxide. Same is the case with the barium hydride. It forms barium hydroxide. Okay, and there is a liberation of hydrogen gas. Okay, so calcium hydride, when react with the HCl, it forms calcium chloride, and strontium hydride react with the HCl to form strontium chloride. Okay, ethanol react with the calcium hydroxide. Now see here the case. Ethanol reacts with the calcium hydride. It forms corresponding salt of, or you can say calcium ethanoate. Calcium ethanoate. Okay, now see. These hydrides are also good reducing agent in the metallurgical processes. They are also used as a dehydrating agent for the organic solvents. Okay, and They are used in different reaction. Okay, so depending upon nowadays also people are trying to use these hydrates in different chemical reaction. Okay, research is continuously going on. Here are some limited uses what they have mentioned. Okay, but this is okay for this level. So this is what all about the hydrates of first and second group element and the paramagnetic nature of O2 minus ion. Okay, so I'm going to stop this lecture here. Remaining we'll see in the next lecture. Thank you.